We're going to be working on factors that affect reaction rate. Remember that if you miss something, you can go back. But the last time we were having problems with the video. So if you have issues with that, we can. You'll probably have to get the end of it from somebody else.
Is it one of the things we just picked up today?
So what we picked up today is a lab that is going to be required to get done. So we'll talk about that as we go. Yep. So we are right here. We are going to do red and green rotations, but I switched it up. So in the green, you're going to do working on your Learn Smarts. In the red, you're going to do the experiment. So it's going to be what is on the board, not as what's on here. We're going to be talking about factors that affect reaction rate. So in your lab, sections A through D on the lab that you're going to do are about factors that affect reaction rate that you're going to be using a clock reaction. And a clock reaction will actually be clear and all of a sudden turn a color. So we're going to be adjusting different things in it and doing different things with it. But when you get to Part E, you actually get to make I'm going to show you 3 experiments. You get to choose with your partner what you're doing with it, how you're doing with it, what things are going on with it. Okay? So as we work today and you go into working on your pre-lab, I want you to skip to that part of it where you have to work with somebody else to do the pre-lab before so that you can get the things done that you need to. I'll come in and check in real quick. Okay, go ahead. Okay. All right, so first of all, who can remember all the 5 ways that we can affect rate of reaction?
Sample size.
Okay, so concentration, particle size, catalyst,
Volume.
pressure. If there's a gas, you can do, yes.
Did we put this in the notes?
Yeah, we did. Surface area, particle size, yep. And the last one's sort of hard. It's nature of reactants. So the nature of reactants would have, if it was pressure, if there was a gas, we could affect it with pressure. Also, underneath nature of reactants is, will something actually react or not? Okay?
Yeah, it's not going to react.
It'll never react. And we talked about that with those equations. Remember, one went slow, one went fast, one wouldn't react at all. So that happens. As I show you these experiments, I want you to be by somebody that you're going to do the experiment with. So we have enough in here, I think, that everybody has a partner. So you 3 are going to have to split up, and you 3 are going to have to split up, so we have 2 groups, or 3 groups of 2. So I don't know how you're going to, the 2 end green ones, we're going to have to split up. So we've got 2 girls and 2 others. There shouldn't be, because there's 3 on that table. There's 3 on this table. That's what I'm saying. The 2 threes have got to make 3 groups of 2. Okay? All right, so I'm going to talk through each experiment first, and then I'll show it to you in just a minute. So the first experiment in Part E is reacting sulfuric acid with sodium sulfite. This one is one that we will do in a Petri dish. And as we do it in the Petri dish, some things that you need to be aware of. I forgot to put the safety things on here, but so listen, because that's on the white part. It asks you for safety. On this one, it makes sulfur dioxide. If you have contacts, this is one you need to be very, very leery of, because sulfur dioxide, when it hits water, becomes sulfuric acid. So on this one, as long as you quickly put the lid over and keep the lid on until you get it in the sink to wash it off, and turn the water on first before taking the lid off, and directly put it in the water, then the sulfur dioxide will mix with the water and make sulfuric acid go down the drain. But if you open it up, then it opens up the gas to being in the room. So we want to open it up underwater. Does that make sense? Okay, so that clean up on that. And I'll go over that a little bit more when we get there. We're also going to be doing reacting magnesium ribbon with hydrochloric acid, and that's going to be done in a well plate.
How many times have you done it? What have we done that so
We have done it a lot, and they overuse it and use it some more. So this one will give off hydrogen gas, but it also forces some of the hydrochloric acid to go into to aerosol. In other words, become a gas. And so you don't want to lean over this one. This one is also one you need to be careful with if you've got contacts in. Just keep your face back away from it. The last one we're going to be doing is Alka-Seltzers in film canisters. And I have given you the equation for that. And we're going to be testing both the time of the reaction on this one and the height of the reaction, or how far it will go up and around. Okay? I think you did pretty close. Okay, so on each of these that you're going to be writing up on your own, you're going to need to write a balanced equation. You're going to have to come up with a problem. The problem is very easy. For instance, this one's on concentration. So for the problem on this one, I would put, how does concentration affect reaction rates? Okay, so that would be my problem. My hypothesis is I would have to come up with something. How do I think it's going to affect it? Well, the higher the concentration, then what's going to happen to the reaction rate? Anybody know what IV is?
IV?
Mm-hmm. There's a lot of different ways to do IV, yeah, but that's not what we're using it in chemistry for.
IV. Can you show me what it looks like?
Independent variable, good. So what is an independent variable? Does anybody know?
It's like time, it doesn't change.
No. When you think about independent variable, think about I. I'm changing this. I'm affecting this change. So the independent variable for concentration is I'm changing the concentration of something. Okay, so you've got to tell me what you're changing the concentration of. Dependent variable is what changes because I changed something. So hopefully the reaction time is going to change. So we're going to put dependent variable as a time. And the controls, are the C's, are the things that are not going to change, the things I'm going to hold constant in the reaction so that I can see how what I changed really affects it and all. Now, I've got numbers here for procedure. You do not have to use all the numbers for the procedure. But the procedure needs to be written in a way that somebody else can pick up your procedure and do the lab the way you want it done. Huh?
Well, the last lab we did from Weber.
Don't, yeah. So this is, yeah, Weber doesn't do that. We need to do that. Okay, so you need to write it in a way in which someone else can pick up your lab and know exactly what materials to pick up, what to do with those materials, and how to write the equation down. Up here in the data table, some confusion over the last two periods. Let me just explain this. Put whatever you like, put above in between data table and the table here, put this first column as being your trial number. Then in the next couple columns, explain what you're doing. So for instance, if I'm changing concentration, maybe I put this much of a concentrated acid, and this one would be my number of distilled water drops, and then I put the time. For the one that we do, the Alka-Seltzer, you're going to need to have a height and a time column, okay, along with a trial column. You want a minimum of 3 experiments. That's not great, though, for data, because if one of your experiments fails, then you have 2 points to make a line, and that line might be way off, so your R value might be very high. As you get more points in a line, the R value goes down, hopefully, if your points are on that line. Remember, on a graph, the x-axis is your independent variable, the y-axis is your dependent variable. And then on the conclusion, I did not put claim, evidence, justification, but you still need to do a claim, evidence, and a justification or reasoning. Your claim should be, for instance, the effect, the higher the concentration, the higher the rate. The evidence, when I was at this experiment with this concentration, I got this time. With this experiment, this concentration, I got this time. The justification, because the concentration increased, then the reaction rate increased, decreased, whatever. Okay? So you need to do that for each of them. Make sure you're watching up here. A lot of them are not concentrating on the concentration or particle size or temperature at the top. Make sure you're putting the right one on the right page. All right, so what I'm going to do now is I'm going to do some of the demos for you on the different things that we just talked about so that you can see real life what it looks like. The first one that I'm going to do is the Petri dish one. So you're going to pick up a Petri dish. Let me get it. There we go. And in the Petri dish, you're going to be using your sulfuric acid, okay, H2SO4. We're going to be using universal indicator. They'll change different colors and different things. And we're going to use sodium bisulfite. Okay, so I've got a Petri dish. The first thing I want to do is put the indicator in.
What is the indicator made out of?
It's universal indicator has several different chemicals in it, but it's usually just a chemical that will change colors depending on the amount of hydrogen present. Okay, so I want to make sure that they are the same color to start with. That's important because otherwise my Petri dish is not clean.
You got 2 different dishes, right?
I've got a lid and a bottom. Okay, so then opposite the indicator in this one, you're going to put so many drops. Now in this one, if you're using it for concentration, I would pick a total of 5 or 6 drops, and you would vary it like this. 1 drop or something like this. 1 drop of sulfuric acid to 5 drops of sulfite. Then 2 drops to 4 drops, and 3 drops to 3 drops, and then 2 drops to 4 drops. So you keep going down like that. Or you could do it with 5 drops. But your total amount of drops has to be the same. That's the big thing. If you have different amount of drops, it's not the same kind of reaction. You've not held everything steady. So I'm going to just do 2 drops. Now, this is where your partner comes in to play on all of these. One person's going to have to do the experiment. The other person's going to have to time. Okay, so I would take and I say, okay, you ready? And I get this up and ready to roll. And I go 1, 2, you're timing. And on this experiment, you need to have that person that's doing the timing. I'm going to change this a little bit, see if I can get that glare off. Oh, that didn't help. That made it worse. Okay, you're going to have that person timing.
The lights off?
No, because then it'll go off this too. To see when these change. And if you put them, I put them off a little bit from each other. I'm going to change it a little bit and put them next to each other, a little bit closer. You want to be able to stop it at the same time. So the bottom one should be turning, and you can sort of see a little bit. It's got a little bit of yellow on the outside edge. It will have an outside edge that goes yellow, and then it'll go orange, and then the whole thing will go yellow, and then all of it will go orange. It doesn't matter when you choose to stop, but you've got to choose to stop at the same time, each experiment. Okay, so you can see it's sort of turning more yellow-orange now. There's just a little bit of green left. There's orange coming through a little bit more. So you've got to decide when you're going to call that. Okay, but whenever you stop at the same so for instance, this has a little bit of green left in. Do I want to wait till all the green's gone? That's where I stop. Or do I stop this timer right when I see the first yellow appear? You've got to have the same stopping point for each experiment trial that you're doing. Okay? All right, so this is completely yellow or orange at this time. Now, this is where you've got to be careful if you've got contacts on. You want to make sure that you take it over to the sink and you put it under water. So I'm going to do that right now. Why don't you guys talk to each other and see which ones you could use this for? Could you use it for temperature? Again, with temperature, you're going to have to put it on a plate, and you could put it on ice. You could put it on hot water. You could put it at room temperature. You could put it on warm water, that kind of thing. Particle size is going to be a little bit hard because you can't break any particles here. And the other one is concentration, and you can change the concentration. We talked about that. So talk about it with your partner. And we're going to have to break these guys up and get you by a partner, so whoever's not going to be a partner here. Because you need to be while your partner to talk. Are we not breaking up, guys? Who's going over? Who?
Are we doing the lab now?
We're going to be talking about it in a minute, yes. So you've got to talk to them about which one you want to use, and we're going to be writing the procedure. Okay, for the next one, so I used white paper towel under that one. That works better just to do the white. If you try and use the black lab top back there, it's really hard to see the color change. So make yourself a little note there in your procedure, which is your salmon color paper, that you want to make sure that it's on a white surface for that. The one we just did. The one we're doing right now next is the magnesium. And on this one, we do want to do it on the black background. It makes it a lot easier to see on the black background. So I'm just getting one well so you can see one well. We're going to be using hydrochloric acid. You'll have option to use some distilled water, and you're also going to be using some magnesium ribbon. You'll be given a strip of magnesium ribbon, and you have to decide how many trials that you're going to make. I would not do anything wider than about this. So if you can sort of see the difference between the width of that and that. Okay? So half full for the well plate is 30 drops. Okay, I wouldn't go over 30 drops because this one does splatter, and so you want it sort of contained in the well itself. So I'm just going to, this one's really slow. Oh, I'm putting the wrong thing in. That helps to read your instructions. Let's try a different well. Okay, hydrochloric acid this time, HCl, so I'm doing the right thing this time. I was going, that one does not want to drop, and that's why it was not HCl. Okay, so 30 drops. You don't ever want to dilute what I'm giving you more than half. So you don't want to go down below 15 drops of the HCl. Okay, but you're going to, if you do concentration, say I did 30 total drops, I could do 30 total drops without diluting it at all. Then I could do 25 and 5. And then I could do 20 and 10. And then I could do 15 and 15. But I don't want to go past 15 and 15. Or I could do 2 and 30. You know, whatever you want to do. So this is what's going to happen. You put the magnesium in, and you'll be able to see that it is giving off or effervescing hydrogen gas. But it also takes some of the hydrochloric acid and throws it out. So don't be leaning over it. You can see, I can see from the side that yes, that's still working. As it gets down to where it's not bubbling quite as much, then maybe I want to get a little bit closer so I can see exactly when to say, okay, stop, because nothing's reacting. Okay, but I want to stay away from it. It does give you a splatter pattern. So that is hydrochloric acid, so be careful with that when you clean up. All right, so then we would stop it when all the bubbles are gone. So that's how we know when the reaction's over. And you just sort of see the little zoomer going around there. And we're dead. Okay, so that's that one. Talk to your neighbor about what you could use that one for. Again, we could put it on a plate of different temperatures. We could cut that magnesium ribbon down. Put that off to the side. Let's see, this way? This way. Okay, for the next one, you're going to get some effervescent tablets. You'll get one, and you'll want to divide it into 4 pieces, 4 about equal pieces. So you can do 4 trials. And no, they won't be exactly the same. But this is going to be in excess, so you don't need to worry about it. You'll also get a little, see if it'll focus in on this. You'll get a little film canister. And the film canister is not going to focus in on me because it's focused in on the other thing. The film canister has markings on the side, even though you can't see it. Okay, the film canister has markings on the side that say 1/4, 1/2, 3/4. Do not fill it above 2/3 full with water. Okay, if you fill it above 2/3 full of water, you're going to end up with a problem. So what I like to do is I like to measure out all my tablets. Now, if I'm going to use particle size, there will be mortar and pestle that you can use to grind it down. You could take one piece like this and divide it in half with your hands, do a full piece, crumble it with your hands, and then do the mortar pestle to powder it if you did particle size. You could also use different temperatures to do this one in different temperatures. You could, concentration does not work with this one. Okay, so don't try and use that with concentration. Some people think, oh, well, if I take a whole tablet and then I do a half a tablet and then I do that will change the concentration. The problem is you'll have to adjust with your water the same amount problems, and that does not work very well. Right, with water. Okay, so what you're going to do with this one is we're going to take this one out to in between the outer doors and the inner doors, coming in just right here, because it goes all the way to the second floor. And this one will, we have done this in the spring and actually lost film canisters on the top of the school. So you're going to be measuring time and height on this. Okay, so you're going to quickly, you're going to use an ice cream lid or an ice cream bucket for the bottom so we don't make a mess for the custodians because they don't like that. And you're going to put it in. The hotter the water, the faster you want to get away. And you want to make sure you're wearing goggles because we've had this blow up in people's faces before. I used 1/4 of a tablet. Okay, and everybody says, well, what if we use a full tablet? It's enough with 1/4. And there's still left over. You can still see it's still going. So because it's still going, it's still giving off gas. Yeah, only use 1/4 of a tablet, and that'll give you 4 trials. So if you have problems, you can work with that. Okay, so I've shown you each one of them while they're fresh in your mind. Okay, we're going to have you work on Learn Smarts if you're in the green. Red, we're going to work with actually writing up the lab. And so whoever's going to be with together here, I'd like you to come into red because we only have two in red right now. And that'll give me a chance to, if I can have 3 groups come to red and then 3 groups stay, then we'll flip them and then I can help you more individually. Okay? All right.